Hello, how are you doing? We are the Orion Aerospace Design Team. Our rocket for the competition is called Odyssey, and it has an apogee of 3 kilometers using solid propellant. We are a team with 5 divisions in areas: rocket avionics, structure, propulsion, quality, and trajectory. We have several sponsors that help us, but most of the cost comes from the team's cash. So far there has been spent around 3,400 reais, and a cost projection is at least 7,000 reais. Many components are still being purchased to complete the project, and we are very excited to start test flights.
The propulsion area is responsible for providing the rocket with the energy it will spend to go up, in addition to scaling the internal geometry, ballistics, and the rocket engine. Our work begins with the choice of propellant and construction method. For the Odyssey, our rocket, we used KNSB, a sorbitol-based propellant, and the base construction model. After that, we must proceed to sizing and scaling of the nozzle, bulkhead, case, the amount of propellant, and other peripheral components of the engine. Then, the propellant must be cast and some tests must be carried out. These are, for instance, the burn rate test and the static test. All of this is done to ensure the quality and the safety of our project. Finally, the parts are machined and assembled, preparing the engine for launch. Some of our numbers until now. Our propellant mass is slightly over 6 kilograms. Our max pressure is 3.25 megapascal. Our maximum thrust is 2,600 newtons. Our total impulse is 6,800 newton seconds, which leaves us with a M-class rocket motor.
To the check balance, we obtain the static margin that varies between 3.5 and 6, where the lowest value is registered for the apogee. For the calculation of apogee, it was calculated and simulated and covered at the moment an apogee of the 3670 meters with a maximum speed of the 253 meters per second, equivalent to a Mach 0.73777, approximately, with a maximum acceleration of the 93.75 meters per square second is equivalent of the g-force of 9.57. The initial weight of the rocket is the 30.36 kilograms and the final mass is the 24.21 kilograms, which comes down to the internal skeleton skin that the engine's avionics and payload. The rocket skins is made of the fiberglass. The internal skeleton is divided into modules that separate parachutes, avionics, payloads, transitions, engines, and fins. These modules are made carbon fiber honeycomb washers and carbon fiber rods. The fins are made of the 3D printed carbon fiber.
We've already done 2 burn rate tests, 5 pellet samples in total. About future tests, we plan to do a parachute test to guarantee that the recovery system is functioning correctly. A combustion chamber pressure test to verify if there are any leaks or manufacturing failures, and to confirm the maximum pressure supported by the motor. A fluxural test to guarantee the quality of the material that will be used in the body of the rocket. Finally, a hot fire test which obtains the thrust during the time of propellant burn.
The recovery system is responsible for returning the rocket in ideal conditions. It consists of a dual activation system with a drogue and a main parachute. Activations will occur by means of pistons using a pyrotechnic charge system. That is, the pressure generated by smoke from the gunpowder will eject the parachutes. This will be in 2 different times: the precursor at apogee of 3 km determined by the speedometer, and the main one activated at 300 meters by an altimeter. The weight of the components add up to approximately 2 kilograms.
Avionics take care of all the parts that involve electronic components, and among these, it is possible to separate into 3 main circuits: the ignition circuit, the parachute activation circuit, and the telemetry circuit. The ignition circuit design consists of a control that will trigger an ignition module that keeps contact with the rocket propellant. The parachute deployment design is based on the idea that when the rocket reaches the apogee of 3 kilometers, the first parachute will be deployed to stabilize the rocket, and then, when it is 300 meters above the ground, it will open the main parachute. And finally, the telemetry circuit covers the entire part of capturing, storing, and sending data from the rocket to Earth. Putting together all the components that will go on board, plus the weight of the PCB, all the electronics will be close to 300 grams.